and continuous professional development and emerging technologies. Dr. Paki Antony Amalan has made significant contributions to research with 12 publications in reputed international journals, including 4 SCA indexed articles, and he also serves as a reviewer for 4 SCA journals, contributing to the advancement of scholarly research in this domain. In addition to his research accomplishment, he has actively contributed to academic development by organizing FDP and serving as a resource person for workshops, including those related to computational fluid dynamics for faculty members. He has participated in more than 8 international conferences, demonstrating his active engagement with the global research communities. So we are indeed honored to have such a distinguished scholar and researchers with us today. I am confident that his valuable insights, experience, and expertise will greatly enrich this session and inspire all the participants. On behalf of the organizing team and management department of mechanical engineering, I once again extend a warm and heartfelt welcome to Dr. A. Paki Antony Amalan. So we look forward to insightful session and enriching the session. So welcome you, sir. So I invite Dr. Paki Antony Amalan to deliver a technical session. Sir, this session is yours.
Sivakumar sir, for your wonderful introduction. Good afternoon to everyone participants. My voice is audible?
Yes sir, your voice is audible, sir.
Shall we start presentation?
Yes sure sir, you can start, sir.
A very good afternoon to one and all participants here, and I express very sincere gratitude to the management, Welltech, Multitech, and Autonomous Institute of Chennai, and Dr. Sivakumar sir. I am Dr. A. Paki Antony Amalan, working as Associate Professor in Mechanical Engineering, PSM, College of Engineering and Technology, Tirunelveli. Today we are going to discuss some interesting topic about material characterization through machine learning techniques.
Sir, how many devices you are using, sir? More than one?
Yes, sir.
That's why that noise is coming, sir. You just take care of this. So please continue, sir.
Okay.
Yes, continue, sir.
The agenda mainly we discuss about first introduction to material characterization. So in this topic we briefly discuss about some fundamental concepts related to the material characterization methods and techniques. Then second topic we are moving to machine learning. That is, we discuss some basic fundamentals about machine learning techniques, and then by using the machine learning technique for material characterization. This is a booming technology. Recently, many researchers are looking to work related to this field. So today, I think this is an interesting session. Please listen and start. Then last, we see some example of machine learning algorithm as a case study problem. First one, what is machine learning? Material characterization. Material characterization is the systematic measurement of materials' physical properties, chemical composition, and microstructure. Because the materials is the basic for all the fields, even any domain in the engineering, whether it belongs to the civil engineering or electrical engineering, electronics engineering or mechanical engineering or aeronautical engineering, material is the fundamental for all. Because every product should be made from the material. Therefore, to characterize the material, whether it is suitable for that application is most important. Therefore, in order to characterize the material, the physical properties, what are the how the material having the physical strength, that is tensile strength, compressive strength, fatigue strength, that properties we go to characterize. Similarly, the chemical composition. What is the composition element? Each element. What is each element having how much percentage and how it look like? So that is very very important. That is a chemical composition and microstructure. How the intermetallic compounds are formed and framed, distributed inside the material. It affects the strength and the tensile strength and the compressive strength of the material. Therefore, in order to predict the proper material, so we have to characterize its physical properties, chemical composition, and microstructure. This is called material characterization. In generally, the material characterization is classified into two major classification, that is microscopic material characterization and macroscopic material characterization. In the microscopic material characterization, we study about the crystal structure and the geometry of the crystal grain boundaries, grain structure, how the grain size, what is the grain size, and before processing and after processing. That and all we have to discuss in the microscopic material characterization. While coming for the macroscopic material characterization, we have to characterize the basic mechanical strength, that is the thermal properties, how much thermal conductivity, coefficient of thermal expansion. This property we have to characterize for particular temperature applications, as well as the strength of the material. So how much yield strength, how much ultimate strength it is having, how much ductility it is having, that we have to characterize. That is comes under the macroscopic material characterization. And electrical, we have to characterize the electrical properties as well as electromagnetic behavior also we have to characterize. It comes under the macroscopic material characterization techniques. Okay. While characterize using the for microstructures, there are so many latest devices we are using now. The optical microscopy and some scanning electron microscopy. Then it is called as a transmission electron microscopy and scanning transmission electron microscopy system and AFM atomic force microscopy. So, as we know, if the researcher joined in this presentation participation, everyone know about that. So we have to characterize in internal crystal structure. We using the XRT image. We have to take and we analyze the peak. So from the peak, we characterize which element it is having in the material. So that we characterize using the XRD and optical microscopy. We can see the microstructure of the material. So in depth, if you want to characterize the material, we can use scanning electron microscopy. So if we go over to analyze nano level investigation, that is we are using TEM, transmission electron microscopy. So in this technique, we can characterize the material by using the atomic level. So scanning transmission electron microscopy technique is combines the TEM and some image. Then atomic force microscopy, it used to scale the atomic scale resolution. So these are some experimental methods to characterize the microstructure characterization. These are the some devices for this purpose. We can see. So next macroscopic characterization. So in this macroscopic characterization, we have to characterize some common mechanical properties, tensile test, compression test, impact test, and stress. We can analyze the stress strain curve. In this property, we have discussed in this presentation, and we have to characterize some fracture analysis. So in the part of thermal analysis, we can predict the high temperature performance, the high temperature environment, how the plastic deformation will occur in the material, and thermal gravitometry analysis, differential thermal analysis, and TME and thermal titration analysis. These are some common thermal analysis we are used for macroscopic characterization. In the same way, the fatigue load, when the material subjected to the constant repeated load, and varying load. So we have to characterize fatigue. So while characterizing the fatigue, it is mainly classified into according to the cycle, number of cycle, high cycle fatigue, low cycle fatigue. So, and if we what are the according to the material testing method, we can characterize into axial fatigue test and the rotary fatigue test. So, from the fatigue test, we can characterize the SN curve for that particular material. So, from the XN curve, we can predict the fatigue properties of the material. These are some fatigue analysis. So, similar way, we can characterize the corrosion properties, electrochemical corrosion, immersion corrosion test. From the corrosion test, we can analyze the Tafel plot, corrosion rate, and Bode plot. So these are some common mechanical thermal fatigue and the corrosion test we are carrying out in the material by using the conventional experimental method. So up to that level, many of the researchers are working, and mostly publications came from this microscopic and macroscopic characterization as of now. And even though the machine learning and artificial intelligence are came into the field, so it is having high benefit to the mechanical engineer also, because the traditional methods having some important challenges in their real field, that is high cost. For example, in previous slide we see to characterize a microstructure, so the equipment cost in terms of crores. So therefore we have to characterize the material by using the experimental method, consumes very high cost to characterize a material property, mechanical property, or thermal property. So if you take more number of sample, it is having highly it involve more amount of cost, and time consuming. So time consuming also, it is a most important factor, because if we go for the multiple number of experiments, if we analyze we have to analyze 100 or in terms of 1,000 materials to predict the mechanical properties, it is consuming lot of time to predict the properties of the material. So in the same time, the material preparation from any other liquid processing or powder metallurgy or anything, so it consumes a lot of material wastage also, and the limited scalability also it is facing. We are facing in the previous years. So due to these broad challenges we are facing, the mechanical engineers to characterize the material. So the artificial intelligence technique is a booming technology in recent years. So we use this artificial intelligence fundamental concept in mechanical field. That is very, very important. So up to that level, so as we told earlier, so we discussed some basic fundamentals about the basic experimental material characterization techniques. Now we go for the artificial intelligence method. So before starting to the artificial intelligence method in deep, so I explained some what are the basic concepts, how the what is artificial intelligence, what is machine learning, what is deep learning, I have to explain. So then we combine the machine learning techniques into mechanical characterization. Okay, the artificial intelligence is the branch of computer science that enables machines to simulate human cognition, including learning, reasoning, problem solving, and decision making. That is one the definition of the artificial intelligence. Artificial intelligence is similar to our human brain. So see this diagram. So this the whole circle is called artificial intelligence. It was introduced in the 1950s year. So artificial intelligence covers machine learning and deep learning concept. So machine learning comes inside the artificial intelligence domain only. So apart from the machine learning techniques, we are moving to the deep learning techniques. Nowadays, the deep learning techniques are booming very well. So this is the general architecture of the artificial intelligence techniques. So to characterize if we involve artificial intelligence to predict the material properties, this is some basic procedure we have to follow. First, it will start from Python programming, because every machine learning problem algorithms work background is Python program. So to characterize a material, so first if we use for machine learning, we have to learn very well about Python programming. So then second step is data science. So as we know, so all the material characterization experiments having more number of data. Data is very important. So it large size data and large number of size data is very much essential to predict the some properties using the AI method. So therefore, second step is data science. We have to characterize our data. We have to analyze our data, and we have to some essential work in that data. Then only this data is suitable to use for the machine learning application. Then third step is machine learning. So in the machine learning, there are some major classifications are there. That is we will discuss in the upcoming slides. So using this machine learning algorithm, we have put some algorithm. Which algorithm is suitable for that purpose? So that algorithm we can use for this data. So the outcome of the algorithm is predict the new material or whatever analysis you are looking forward. So that output we can get from the machine learning algorithm. So that output then we characterize according to its performance, how much accuracy, how much error in that algorithm, because it is a computer based only. So therefore we have to characterize that result. So then only the result is validated result to the society. So this is a very fundamental step. So once again I repeat. So to work in the machine learning, we have to learn the Python program very well. So after Python, using the Python programming coding, then we use the data science concept. Using the Python program itself, we can analyze the data, and we have to work some important work in the data science. So then apply the machine learning algorithms. So using the algorithm, we can predict some outcome. So then once outcome came, so we have to evaluate the outcome. How much accuracy, how much error of our result. So then only the new prediction will come using the machine learning techniques. So it is no need for this much experimental cost, time consuming, and high amount of cost. It is very simple and very fast method. It is very much helpful to the material researchers in the nowadays. So we have to discuss some basics about the Python. Python is a popular programming language. Everyone know about that. It is released, created by Bida 1000, released in 1991. It is used for software development and for web applications. It can connect the database systems. The Python program we can use connect with the data. We can Excel data, CSV file data. We can connect with the database system, and is mainly used to perform the complex mathematics calculations. The Python working the different platform, Windows platform we can use, Linux platform we can use. So it is another one important parameter is interpreted language. Python is interpreted language. There is two types of method is to execute the program. In the C++ program, there is a compiler and the interpreter is there. Compiler means the total program from starting to end of the program will run in the one time. So that is a compiled program, but Python is an interpreted language. So if we give the command code or in each every line, so the Python is execute every line. Then we get it gives it is called interpreter. So in the same time, due to the interpreter, Python is slow compared to the C++ language, and it requires indentation space and it caps everything we have to follow in the Python program. Otherwise, the result won't come. So it is a free and open source software we can download from the web and we can use. These are some basic important Python libraries. So while seeing the coding, you can see this library in my presentation. So before going to that, I have to explain what are the important library, what is the main purpose that you have to understand. That is a NumPy. It is called NumPy in the Python program library. So this library, while importing NumPy, so we can use for numerical computation, arrays, matrix, and mathematical operation. We can use this library. Another one important library, Pandas. Pandas library is mainly used for data manipulation and data analysis. For Excel data or CSV data, we can must import the Pandas and the NumPy libraries. And Matplotlib, this library used to visualize the plot graph. If you want to analyze the outcome of the plot, so you have to import the Matplotlib library. and the Seaborn library used for the statistical data visualization, and the scikit-learn, it is used for machine learning algorithm and model evaluation. TensorFlow is used for deep learning and neural network problems. Keras library used for high-level API and building neural network problem. And these are some another one important libraries, SciPy and OpenCV and StatMods. These are important libraries before apply the machine learning algorithm in the Python program. The first step, we have to import all the libraries in our code. Okay, once this is not enough time to discuss all these concepts very well. So I touch the simple fundamental principle and tell the important points about the Python programming and the data science only. So if you want to carry further research in your domain in future after this FDP, you can learn very well. You have to spend 2 months or 3 months. You will learn Python programming and you write coding. Then you apply the data science concept that will take another 3 to 6 months it taking to characterize the data processing technique. Then you learn apply the machine learning concept. Then you can be able to handle the material characterization technique to machine learning methods. So now in this platform, in this short period, 1 hour or 1.5 hours, I can touch the important points only. So this is the data processing. So initially every data coming from the experimental methods. So it is not a standardized one or it's a correct one. So what it represents means it required data cleaning. So we have to identify any abnormal data or it is called outlier. Outlier means if the Excel data having 0 to 100 value in one row and another row it varies from 0 to 1000. But if only one data only it is having in terms of lakhs or crore means that is comes under the outlier. It is the CSE people will told that outlier. So that we have to characterize, that we have to check or this data we have to remove from the Excel data. That is a data cleaning. In the same time, the Excel data having row value but not column value in the particular data. So that we have to check if any missing values are there or not, any abnormal data is there or not, any noise is there or not. Noise means the random error or variance from the measured values. See the diagram. The circle encircled is the standard data. This is the outlier or noisy data. So that general data we have to characterize and remove. If we want to find some mean value or median value, then we fill the missing values. So then we can get the structured data. So summary, the data quality is very important. The accuracy, completeness and the consistency of the data is called terms quality. The quality of the data is very essential once before using the machine learning algorithm. Otherwise, we get error result only, that it is not used for the material characterization. And the data cleaning is the second step. In that step, we have to check the missing value and find the suitable method to fill the missing value. Otherwise, we have to remove that content. If it is important, we have to use some predict some mathematical method to find the value. These work have to be carried out before going to the application. And the data integration. So in that data we can use for this algorithm. So that is integration part. If we want to carry it out, that also should be carried out in that process in the during experiment. And the data reduction that I told, if the unwanted data or outlier data we have to reduce from the structured data. Then it is in some data have need normalization operation. We have to convert the x value in terms of logarithmic table or normalized table. That is called data transformation. And discretization. If we want to discretize some of the whole data into small domain, that process also we have to carry it out before apply the machine learning program. So these are some data science book as well as machine learning book. Please note down this book. It is very helpful. It is in that book. Every Python code will be available in that book. So once we download the Python program. So we can copy and paste the code from the textbook. We can check the outcome, how the data will be worked like that. We have to practice from the scratch. Okay, these are some concepts about yeah, artificial intelligence. So as we see in the earlier slide, so in the artificial intelligence domain, the second part is machine learning. So machine learning it is defined as a branch of artificial science, artificial intelligence that focuses on developing models and algorithms. Model means that predict one mathematical formula that is called the model, the developing model as well as algorithms. So there are so many algorithms are there in the machine learning. Then that let computers learn from data without explicitly programmed for every task. That is very, very important. So what is learning? Machine learning means the computer learn from the data. That is very, very important. We give all the data. So from the data, we give some these are the cat, these are the dog. So if the cat look like this, if the ears, if the nose look like means it is cat. If it is dog, if it is a numerical value, it is having the suitable or not like that. So much data we are giving input. So from the input and the machine learning program, the computer learns something. So this is if the given data is like this means the output will be like this. So like that the machine will be learning. That is called machine learning. So in simple words, machine learning teaches systems to think and understand. That is very, very important. We train the computer to think like a human brain, then understand like a human from the data. That is very, very important. In general, machine learning is mainly divided into three types of machine learning algorithms. One is supervised learning, another one is unsupervised learning, and reinforcement learning. Supervised learning means we give some labeled data. If the participants already learn from individual machine learning, they should easily understood my presentation. So supervised learning means we give some label. Label means if the input is given, if the input is like this is output. So if we predict a new material, if we give the new data, so the output is mango or banana. No, yes or no. The system will predict. That is supervised learning. Unsupervised learning, we didn't give any label data. So we didn't give any output. So from the pattern and data itself, it finds the result. That is unsupervised learning. Reinforcement learning, it is understood the result from the trial and error method. So the autonomous car nowadays without the driver itself, the car will be run. That and all comes under the reinforcement learning. So if the sensors and look like the road, so it take award and punishment if the according to the obstacle present in the road. So that and all comes under the reinforcement learning technique. So this is called supervised learning. In the supervised learning, as we told, some label data. So we give some more image, the camel, elephant, like that label data image we are given. So labels, we are given this elephant, it is look like. If it is a cow, it is look like that. If camel, it will look like that. So these labels we give in the we give to the system through the program. So then training the data set. So if we give in terms of thousand, in terms of lakhs of data, so the system will train according to the input data. Then it will predict some output. So then if we give one image, if we give the cow image in the last prediction, so algorithm will correctly give the output, it is a cow. If it is a categorical data, it is a cow or not, yes or no. If the email, it is a spam mail or not spam mail. If your mail came to our Gmail, so it is two categories are there, everyone know about that. The spam mail and the spam mail. So if the spam mail automatically goes to the spam folder. How it is happening? From the supervised machine learning only, it is happening. The mail mail having some labels from the unwanted web source, unwanted labels. So it automatically it understood it is a spam mail. Then the mail goes to the spam folder. So that are all working from the machine learning principle, supervised learning principle only. So not only the categorical result, regression result also there. Regression means the continuous numerical output. Not in the categorical data, yes or no, spam or not, like that question. In regression, not like that. It is a continuous output. For this output, this is the output. Next incremental, this is output. Next incremental, this is output. Like that, the result will come. That is called regression analysis. In some machine learning algorithms used for this supervised planning is linear regression, logistic regression, decision trees, and coming. So first linear regression using the straight line prediction. Everyone knows the equation of the line y equal to mx plus c. So use that equation is very much used in the linear regression machine learning problem. So it predict the new accelerated property. The logistic regression is use the yes or no category, and the decision tree means it is simple question. If it flow chart, if one result came, it is yes or no. If came, again one question is there. So that condition satisfied means again trees will become. So that is a decision tree algorithm. So each algorithm take minimum 10 days to learn because every algorithm having mathematical equations. So we have to substitute the mathematical formula. Then only we can able to understand what is regression. So in that platform, I explain some outline only. So this is the linear regression. So if we the covers and the scores plotted in the graph as shown in figure. So in the first hour, this is the score. Second hour, this is the score. So it is connected by using the equation of line y equal to mx plus c. So see this line. So this line covers all the data points. These orange colors 6 points are data points. So if we plot some one line, if y equal to mx plus c, y is the output, the response. What is what we have to find, that is y. Slope is the dy by dx, the slanting of slope of this line. Then x is the explanatory, the input value. Y is the bias. It is called bias. We use in the machine learning. Otherwise, it is called intercept. So if the data points are plotted in the xy graph, so if we use the y equal to mx plus line, first dotted line, you see the black dotted line. It didn't covers 1, 2, 3, 4 points. It didn't covers. It covers only 2 points. So therefore, we slightly increase or decrease the slope of the line. So which line covers more data points? So that line we have to predict. That is a linear regression. So once which line covers, if it is having 6 data points, which if the line cover 4 or 5 points means we fix that line as a perfect linear regression line. In that prediction, so with the before if we give the new data, so this is a green is a new data, so we can predict the y value. That is a working principle of the linear regression. For example, the actual and the regression lines, if we use the machine learning program, the output will come like this. This is the red line is the exact prediction line with the minimum error. So blue colors are look like the data points, our given data points. So how much accuracy of this plot algorithm we can calculate from the program. So then we predict some new data. Already the plotted blue color data are arrived data, our experimental data. So if we give the new data within the 10 or 12 like that, we can predict the score. That is the linear regression analysis carried out in the machine learning. So this is a fourth diagram is a decision tree. Decision tree look like this. One node it is divided into yes or no 2 category. So if we give some another condition, so it again each node is divided into 2 category. If we give some another condition, so it again is classified into 2 category. So these are decision tree works like this. So all these algorithms based on only mathematical calculations, rigorous mathematical calculations working against this algorithm. So if we give some code, the computer will work this algorithm. Otherwise, we can calculate manually to predict this linear outcome of this program. Another one is support vector machine and k nearest neighbor KNN algorithm and naive Bayes algorithm, random forest algorithm, and the ensemble algorithm. So all these algorithms comes under the supervised learning, machine learning techniques. So this is a support vector machine concept. So the green color data are one group of data and blue color data are another group of data. So all these data we arrived from the experiment. So if you want to classify the data into two categories, so we arrived one classifier, that is a support vector machine using the one line equation. So that black color line divides the blue data and the green data. So we calculate the distance between the each point to the reference line. So if it is more, so it doesn't cover some more data point. Therefore, the hyperplane, the margin will be somewhat added in the positive direction as well as negative direction. So we can increase the margin of the classifier. So if we increase somewhat more, so it covers some data points with minimum distance. That is comes under the support vector machine, and regression analysis it is called SVR algorithm. So KNN algorithm means the number of K will be framed from the data. If you classify into this orange and yellow color, so we frame one circle is a one KNN, K equal to 5. We frame this under comes under this category. This comes under this data comes under this category. So like that, KNN algorithm will work. So if we go for the unsupervised learning, that is the two main algorithms are there. One is clustering, another one is dimensionally reduction. Clustering means it's a group of data. So see this diagram. Clustering means if the data is present in the XY plane like this, so it is grouped into some geometry. It is a circular or rectangular or anything you can plot. So these data are belongs to some category. These data belongs to some category. If we used for this EAG calculation and many applications on unsupervised learning using the clustering algorithm only. So this is the supervised learning. So see this classification, it is important. All the data are input data. If we draw some line, that is a classifier. So that classifies the data whether it belongs to this category, yes or no. That is classification. Clustering means we group some data. So apart from the total data, we group some 50 data into some category. We group some 50 data into some category. That is clustering technique. So see this diagram. This diagram represents this concept. Another third machine learning technique is a reinforcement learning technique. So as we told in the previous slide, reinforcement learning technique is for autonomous car driving. So it is the environment, agent is a model. It is a model. The agent is moving, and it is getting some output from the environment. We have to stop. For example, if you use a robot cleaning inside our home, it is using this algorithm. So robot moving towards the wall. So if that's the sensor means, so the robot shouldn't go beyond that. That is called environment and feedback. So from the model, if we construct a model, from the model we apply some feedback, positive feedback or negative feedback. That is called under model-based method. And if we didn't use model, it's a model feedback. Both are considered the reinforcement learning. See this diagram. So the car is autonomous driving. There is no driver required to drive the car. So every system autonomous component sensor are working based on the machine learning and principle. So it senses a car coming in front and the back side of the back, any obstacles are there. So it will sense the distance and it will velocity, acceleration, everything. So from that data, it will predict, it gives some command to the another drives. So we can go further or we have to stop from the car at this point. So like that, autonomous car will be working in nowadays. So in the future, many of the autonomous car will become this reinforcement algorithm. And another one important machine learning algorithm is neural network. This comes under the CNN method. So that is an artificial neural network. It is highly similar to your brain neuron. So how our brain having neuron, so that we frame the neuron by using the mathematical formula, using the program. So there are so many inputs. See the second diagram, x1, x2, x3, x3 infinities are there. So there are inputs. So if you see the last diagram, the output parameter, what are the these output parameter? If it depend upon some so many input parameter means, so this given using in the x1, x2, x3 like that. We can give the input. So then it transfer to some mathematical formula, mathematical model. That is see this diagram, second diagram. That P represent bias. It forms a weight vector and a distance Wixi summation of I to n Wixi and some function f of z represents some function. If some machine learning algorithm use some Rayleigh obligation, the Rayleigh formula, some machine learning algorithm use the 0 to 1. That is a mathematical binomial method. So that mathematical formula is called f of z function. Then we apply the equation. So we predict some output in the for y value. So see this last diagram. This is the ANN diagram. These are all input parameters. The first layer is input layer. So in the diagram it represented in x1, x2. Here not represented, but it is image only given. So after performing this calculation, P plus summation of Wixi, so it is connected with the hidden layer, second layer. So the first input parameter, for example, the resonability of the material, it depend upon the hardness of the material means the hardness how related with the another parameter. Secondary layer, that is marked using straight line. So like this, each every input parameter, how it is connected to the output parameter. So in between the input and output layer, there we can send the hidden layer. So each every layer we predict some outcome. That outcome give to another input. That input give to another input. Like that, the hidden layer will be done. So apart at last we can get the output. So what is the reasonability problem? Any output we can predict by using this method, but it is a complexity of the problem, and if we use a high power computer only, we can use these algorithms ANN and CNN we can use for this for our application. So these are some links to how to download the Python program from the net. If we for the Windows OS, so we can use this. We can go for this link. If we use for the Linux platform, so we can directly download from the open source. So once you download the to work in the machine learning, before that we have to download the Anaconda Navigator. So once we install in the Anaconda Navigator, so in the Jupyter notebook, we can use this platform to work the Python code as well as machine learning algorithm. Now in this presentation we move the third recipe. First we have characterized about the experiment method. So up to previous slide I explained somewhat briefly about some what are the algorithm, what is AI, what is machine learning algorithm, what are the two classification, supervised and unsupervised reinforcement learning. These are some basics. So after this FDP program, you have to learn thoroughly any NPTEL course or any tutorial or any video referring textbook. You can learn Python program as well as data science. So once if you using this machine learning technique for material characterization, this is the first step. You have to download the Anaconda Navigator, then you got to install it. Then you use Jupyter notebook platform to work the machine learning code. So this is a microstructure prediction using the machine learning. The some image. So in this microstructure characterization, we are unable to use directly linear regression or SPR or random forest like that. So it based on CNN, that is called convolutional neural network. So it occupies memory very much. Therefore, if you analyze the microstructure images, so you can go for CNN as well as the high-end computer only. We can use for this purpose. So if we give the microstructure as the training data, so we can predict some model. So from the model, we can evaluate the accuracy and the error value. So from the error and accuracy value, we can put give some input value. So then we can get the output value. This microstructure is capable for this application or not. This is the main principle. See this diagram. It coming. It will look like this. If you work in this microstructure using the machine learning algorithm, we can predict the output like this. See this diagram. So for macroscopic characterization to predict the strength, tensile strength or the stress strain curve, we can follow this procedure. We can use any supervised learning or unsupervised learning. So first step is the data collection. So collect the more experiment number of data. How much the number of experiment will give to the machine learning? You are predict higher accuracy. If you give very less data, less than 200 or 300 data, the result won't having higher accuracy. Therefore, we can give minimum so in terms of 1,000, 10,000 like that input data we have to give to study the system to predict the output. So with second step, we apply some machine learning algorithm, that is supervised learning algorithm we discussed in the previous slide. So we can use any algorithm. So from the algorithm we can predict some output. So this is the formula for calculating the accuracy and error. And we can calculate from the output of the algorithm. So then we train and iterating then the final time then the result will is the mathematical result you can get. So not only the microstructure, you can predict some numerical property. So we can use this algorithm and predict we can plot and line chart we can use for this research and comparison work. This is some example of raw data and field data. As you earlier, if the data, the experimental data having missing data value. See this graph. So this data they are getting the variation with the UPF conductivity only corners having. So we can structure the data by reducing the missing data, noisy data, outlier data. We have to frame the data or modify the data into structured one. That is very, very important. That is the data processing. So as we told, first step is collecting the data, then processing the data. So this plot represents how many count the missing data are having. These also we have output from the machine learning program. So once after the field work also we can plot this plot. So there is no missing data value in it. So there is okay, the data is structured one. So once before any you have to apply any machine learning algorithm, you have to do this process. So we come to the last experiment. So for in this presentation, I have some example or case study to predict some tensile stress strain curve using the machine learning algorithm. So why we go for the tensile stress test, we can use we conduct for any material because from that only one test we can predict this much property of the material from the test, the elastic limit. So what is the elastic limit of the material? So beyond if we apply the load beyond this elastic limit, what is the yield point? So then what is the maximum ultimate sensation that material is having? If we apply the load further, so what is the breaking point? What is the stiffness? What is the toughness? What is the ductility? What is the property? Plasticity, resilience, and the strain hardening coefficient. So all those properties we can predict using the stress strain curve analysis for any material. So usually we are preparing different only. So once the experimental data arrive and from the previous publication data, we can use for the machine learning algorithm to predict the sustain curve for the new material. So in that purpose, the input feature we are giving this analysis stress value, stress value, strain value, material composition. What is the composition of the material? What are the method? How the method is used to predict the material? What ambient conditions the material was tested? These data we have to give as the input data. So then what are the suitable algorithms we can use for this sustainability? Yes, we are as we see in the support the algorithm use across the elementary ANN, ensemble, all these algorithms we can use to predict the stress curve. So these are the performance metrics of the algorithm. That is the accuracy, R square, and ME mean observed error, and RSST root mean square error. So from the error value, we can characterize which algorithm having minimum error, which algorithm having maximum accuracy. That algorithm is suitable for this application. We can give the outcome from this machine learning program. So this desired outcome stress strain curve we can plot using the Python code. So not only stress strain curve, we can predict some ultimate strength value, yield strength value, ductility, toughness, every value we can get from the machine learning program. So see, this is a sample Python program, and tensile sustain curve. As I told earlier, we have to import some useful library for that before implementing before apply the data. So pandas I told already, import NumPy pandas is very essential to carry the data analysis. That is the Excel data as well as mathematical calculations. So the libraries are we have to import, then load the Excel data or CSV data into the program by using this code. Then we give some training to that system. That is this is strain value, stress values, and what's the plot size, and how the label are represented the plot stress value, strain value, title of the plot, everything we can give in the code. So if we run this program, so it becomes stress strain curve will become like this for any material. So for one stress strain curve data, so we can plot the stress strain curve. So in the similar way, if we work for multiple number of material, more than by material or 10 material, also we can put in the same code by using the CSV data. So from the program, we can plot the strain curve for each material. So this diagram, right-hand side diagram, represents the ductility value, actual as well as predicted ductility value, and how much accuracy of this algorithm. That is 98.94%, and means for error 9.8 error. So if we use for this result belongs to one algorithm. So similar way you can use for many number of algorithm. So then also predict some result. So from the algorithm we can give the conclusion which algorithm is suitable for this particular application. So in the previous slide we explained the stress strain curve we can get. So in this program, in this slide, I plotted some of the properties, material properties, that is ultimate tensile using the SVR algorithm, the support vector regression algorithm. So this is a dotted line represents the exact predicted value, predicted line. So the blue dots are the input data, input UTS. So this represents if we give more than 200 or 1000 UTS from the previous publication or previous reference experiments. So we can predict some UTS without doing experiment. So for this condition, how much UTS value will be occur for this material? That and we can predict using this SVR algorithm. This is Python code. First, we have to import all the libraries. We have to import that file into the program. Then we give this is training data and test data. We have to split the 80-20 0.2 means with the person if we give 1000 data, it will consider 800 data as a training data and 200 data as a testing data. That is 80-20 ratio. Then we give some scaling value and test the model. XV train x underscore test this code give the train and test to the system. So then we plot some result R square value, print the R square value, print the RMS value, the outcome indicate the result. So then plot between actual and predicted UTS. This is the actual predicted value. This is the predicted UTS value. So if we run the code in the platform, as I told, Anaconda Navigator Jupyter Notebook, the outcome will come like this. This is UTS by using the ANN algorithm. In the previous slide, I shown by using the SVR algorithm. So if we use ANN algorithm for the same data, so the result comes like this. So from ANN algorithm, we can calculate the accuracy and error value. So compare ANN and SCR algorithm. Similar way, if you use the RF means random forest algorithm, this is the random forest algorithm code. So if you run the code in the notebook, so we predict the UTS. This is accuracy and error value for this algorithm. This is the third algorithm. So if you use for the decision tree method, this is a decision tree algorithm result. So in the slide also, in the presentation also, I explained four algorithms. That is SPR algorithm and ANN algorithm and random forest algorithm, decision tree algorithm. So from these four algorithms, we can give some we can get some conclusion how the UPS value for the new material or new condition. What is the new sustain curve for the new material? We can predict from this algorithm. This is the decision tree layout we can got in the code itself. This is another one important output we can from the machine learning algorithm. That is a correlation matrix. Correlation matrix means that UTS how it is related with the Young's modulus of the material. Elongation how it is related to the yield strength. So like that one matrix we can get from the machine learning program. So each one parameter how it is related with others. Modulus and modulus one. The diagonal all the diagonal are having one value. So in the upper matrix and the lower triangular matrix, the values are varying according to the relation. How it is the result in the result of the machine learning. So how it is how much percentage it is related with others. Yield is related with the failure. How it is related with that is we can get from the correlation matrix. That and that also we can use in the machine learning code and we can get the output. So these are some reference. So from this, I want to conclude my FDP presentation. And once again, I fastly recall my content. First, about some what is the material characterization and what are the classifications are there, what are the equipments are used, what properties we have to characterize in the experimental method. Then we move for artificial intelligence. So in this platform, we discussed some what are the techniques, what are the algorithms available in the machine learning, what is the machine learning, how it is constructed under the artificial intelligence. In future, apart from the machine learning, it is working on the deep learning method. In the AN and CNN are considered deep learning methods and reinforcement method, reinforcement learning. That is driverless autonomous car working nowadays. So all the what are these algorithms are there we discussed. So apart from next stage, there is how the algorithm used for material characterization. How the algorithm used for predict the tensile stress strain curve. Not only the curve, we can predict each property. What is the yield strength? What is the ultimate strength? We can predict. So we can apply some more algorithm. So we compare the metric performance metrics of each algorithm. So what is the accuracy? What is the error? Their algorithm. From that, all the experiment, all the numerical and experimental work, we can predict a new material with validated and authenticated result. Then we can publish the society and further and the project given source. So up to this, I stop my presentation. I think I didn't pour my participants. So if any participants need to ask questions related to this, please unmute your mic and ask the question.
Thank you very much, Dr. Akash Ramban, for your presentation. So, dear participants, do you have any question? Queries, please kindly ask to Dr. Ramban.
Yes.
Participants, unmute yourself. So if you have any questions, kindly ask to Dr. Bhagyan Ramanan. There is no questions in the chat box too. Professor Bhagyan Ramanan, shall we conclude the session, sir, since there is no questions from the audience?
Yes, sir, we can conclude.
Yes. So thank you very much,
Any
sir.
doubt in future also we can conclude.
Sir, please, sir.
Any doubt asked by the participants in future also we can answer this question.
Yes, yes, yes. So if you have any doubt, there is a contact mail ID and the contact number. You just post your queries to him. He will so guide you.
Sir, I have not received the PPTs of all the sessions, sir. So can you please?
Sorry, sir.
The PPTs.
Yeah, PPT we will share with you, sir. So in a short while, we will share with you all the 12 sessions PPT will be shared in the WhatsApp group, sir.
Okay, thank you, sir.
Yes, sir. Now now we are in end of this session. So thank you very much, sir, for the highly informative and insightful session. So your valuable presentation on material characteristics using machine learning has certainly provided a new perspective for all the participants. Once again, on behalf of management and organizing team, Department of Mechanical Engineering, Welltech Multitech, Dr. Rangarajan, Dr. Saudula Engineering College, I extend my sincere thanks to Dr. A. Pakyatanyamalan for sparing his valuable time with us today. So with this, we come to the end of day 6, session 12 of the FDP. Thank you all for joining us. So thank you, Professor. So we will have a validity function in a few minutes. So stay tuned, participants. So we will start the validity function in a few minutes. So dear participants, we will start the validity function. Um, Part 2, we will start the warranty function in a while. So please stay tuned. So we will start in a few minutes. Professor, Professor, ബാക്കിയാണ് നമ്മള് Professor? Professor Baki and Ramadan, sir?
Yes, sir. Yes, sir.
Okay, shall we start, sir?
Yes, sir. You can.
Yes. Okay, thank you. So, good afternoon to all the respected dignitaries, resource persons, faculty members, and participants. So, I welcome you all for the online 6-day faculty development program on optimization techniques and machine learning for engineering application validity function. So, it gives me immense pleasure to welcome you all to the validity function of the online 6-day faculty development program on optimization techniques and machine learning for engineering applications. Over the past 6 days, the program has provided an excellent platform for academicians and researchers to enhance their knowledge in the areas of optimization techniques, machine learning algorithms, and their applications in modern engineering problems. Today's session makes the successful completion of this enriching academic program. We are honored to have distinguished dignitaries and experts with us for this validity ceremony. So let us begin the program by inviting the program coordinator, Dr. S. Ram Mohan. So, Assistant Professor Department of Mechanical Engineering, Veltech Multitech, Dr. Rangarajan, Dr. Sondala Engineering College. Welcome you, sir. And our chief guest, Dr. Paki Anthony Amalan. So, Associate Professor, Department of Mechanical Engineering. So, PSN College of Engineering Technology, Tirunelveli. I welcome you, sir. It's my yes. Now I would like to invite Dr. S. Ramohan to give welcome address over the FDP.
Thank you, sir. Good morning to everyone present here. It's my great pleasure to welcome the chief guest of honor, resource person, respected faculty members, and all participants to the validity function of the online 6 days faculty development program on optimization techniques and machine learning for engineering application. This FDP was organized with objective of providing participants with advanced knowledge of optimization techniques and machine learning approaches that are widely used in engineering research and industrial application. During the past 6 days, the program featured experts, lectures, discussions, and knowledge sharing sessions delivered by eminent academicians and researchers from reputed institutions. I extend my sincere gratitude to all the resource persons for sharing their valuable expertise and insights. I also appreciate to enthusiastic participants of faculty members from various institutions which make this program highly interactive and successful.
Thank you, sir.
Again, welcome all the dignitaries and participants to this validity function and hope that today's sessions will provide valuable concluding insights. Thank you.
Thank you, sir. So now I invite myself to give a progress report as a co-coordinator. So myself, I'm going to read a progress report of FDP. So good afternoon to everyone. I would like to present a brief report on the online 6-day faculty development program on optimization techniques and machine learning for engineering applications. This program was conducted over a period of 6 days with the objective of enhancing the knowledge of faculty members and researchers in modern optimization methods and machine learning techniques applicable to engineering problems. The FDP witnessed active participation, more than 100 participants from faculty members, researchers, and scholars from various institutions across the country. So during the program, several expert sessions were delivered by distinguished resource persons covering topics such as fundamentals of optimization techniques, applications of machine learning in engineering, data-driven modeling and prediction analysis, advanced optimization algorithms, real-time engineering application of machine learning. The sessions were highly informative and interactive, providing participants with both theoretical understanding and practical insights into these emerging technologies. We received very positive feedback from the participants who appreciated the relevance of the topics and the expertise of the speakers. On behalf of the management and organizing team, I express my sincere gratitude to the institutional management, resource persons, and participants for their support and cooperation in making this FTP grand success. Thank you. So next, I would like to give a participants feedback summary. So on behalf of organizing team, I would like to briefly share the feedback received from the participants. The feedback responses indicated that participants found the session highly informative, relevant to the current research trends, and beneficial for both the teaching and the research activities. The resource persons were appropriated for their clear explanations, practical examples, and engaging presentations. Many participants also expressed that the program helped them gain new insights into optimization algorithms and machine learning tools for solving engineering problems. We sincerely thank all the participants for their valuable feedback, which will help us further improve further academic programs. Now I invite Dr. A. Pakyantanamallan to share a few words about the FDP.
Thank you, sir. Good afternoon to everyone. It is indeed a pleasure to be part of the validatory function of this 6-day faculty development program on optimization techniques and machine learning for engineering application. Optimization techniques and machine learning are transforming the way of engineering problems are analyzed and solved. These technologies play a crucial role in data-driven decision making, intelligent system design, and advanced manufacturing process. Programs like this FTP are extremely important because they equip faculty members and researchers with modern tools and knowledge required for interdisciplinary research and innovation. I congratulate the organizing team for successfully conducting this program and appreciate the active participation of all the faculty members. I hope the knowledge gained during this FTP will inspire participants to integrate optimization and machine learning concepts into their teaching, research, and industrial collaboration. I wish you all the very best in your future academic and research endeavors. Thank you. Thank you all.
Thank you, sir. Thank you very much for inspiring address. So next, announcement of certificate. Participants who have successfully completed the program and fulfilled the attendance requirements will receive their e-certificates, which will be shared with them through their registered email ID. So next, vote of thanks.